Hello and welcome everybody to Howdy Partner, our weekly Twitch series hosted live here on the AWS Twitch channel. Today we have a spatial computing related episode with a very exciting partner, but more on that in just a second. So first, my name is Jerry Tejada and I'm a solutions architect in the partner organization. So my day-to-day job includes a lot of activities with our partners, building POCs and enablement activities and thought leadership, all things partner, and with the goal of helping our customers at the end of the day. So that's enough of me. Right next to me is my partner in crime, Eli. Eli, say hello.
Howdy, folks. My name's Eli. I am also a partner solutions architect here with AWS. So plus one to everything Jerry said. And I've been very interested in the spatial field for years. And so I'm very excited to be here today. And today we'll be introducing you to a cool partner named InnoActive. And InnoActive does some, into Immersal, who does some great stuff for being able to map their environments and augmenting what you just mapped and being able to experience it through a variety of hardware options. And I'll hand it off to Jerry to kick it off.
That's right. So before we bring Immersal onto the screen, we mentioned spatial computing. I'm actually part of the spatial computing technical field community here at AWS. So we're just a technical field community is a group of specialists and enthusiasts like myself. We're pretty much the go-to contacts for all things spatial at AWS. All right, that's enough of us. Now let's bring in Mao from Immersal. Hey, Mao, how are you doing?
Hi, everyone. Hi. We're glad to be here, and it's glad to have the chance to show you the Immersal's VPS technology and also give you a live demo for showing you how to build an application using Immersal SDK.
Definitely. Thanks, Mao. Thanks a lot for being on the show. Super excited to see what Immersal's all about. I know what y'all do, but the beauty of Howdy Partner is that we get to see the solution live in action. So before we jump in, just want to emphasize that with the audience. At the beginning, we might do a little bit of slides for like 5 minutes just to give you some context, but the bulk of this episode is all demos. That's what we do here at Howdy Partner. It's a partner showcase, all very demo focused. So yeah, really excited to dive in. And at any time, ask questions. We want this to be more conversational, laid back. We don't want to just present to you. So please do ask questions at any time, and we'll answer them live here during the episode. All right, that's enough of me. Mao, would you tell us a little bit about you and a little bit about Immersal?
Yeah, my name is Mao Lin, and here at Immersal, I'm the lead of solution and support. Here in my team, we are doing various kind of customer support around the globe. And I joined Immersal about 2 years ago, since the beginning of last year. And before that, I was an AR developer in our architecture and engineering construction company. And I have been jumping into this AR VR field since the year 2016, which is considered as the year of VR. Everything starts from there. And before that, I have about 10 years of software industry experience, but mainly about telecom software before that. But yeah, today I'm here and I'm going to introduce you about Immersal's cool technology.
Awesome. Thanks for that, Mao. Yeah, really cool to hear that you've been in the space so long. I myself am new to the space. I really just got into all things spatial computing about 1.5 years, maybe coming up on 2 years now. And yeah, it's really exciting. All the new devices, all the new technology that's coming out, and VPS is definitely one of them.
Yep, absolutely.
And would you mind telling the audience a little bit before, if you're going to get to this in a little bit later, go for it. But a little bit about what VPS is, visual positioning system.
Yeah, basically VPS is short for visual positioning system. It's basically VPS is like technology which allows you to scan a physical space and turn that scan into a spatial map. And the spatial map is used for localization, or let's say positioning. And the positioning is the key for many things. For example, you can localize yourself in a large space. The space can be, well, from room scale space to building scale space to city scale space. And also you can, on top of the localization or positioning, also you can do augmented reality. I'm talking about not only room scale augmented reality, but also building scale or even city scale AR experience, which is really cool.
Yeah, it is really, really cool. I'm excited to see some of that city scale. I know you do stadium type of experiences and sports
Right.
experiences and museums and things of that nature. So, yeah, really excited to jump in. So, yeah, let's get into it. Floor is yours. Let's see what Immersal's about.
Okay, let's get started. Let me share my screen.
And in the meantime, where is everyone tuning in from today? I myself am in New York City. Eli, how about yourself?
From the state of Texas over in the Austin area. We're finally in decent weather. We just hit 70 degrees today instead of 90.
All right. Awesome.
I mean,
We got El Marble in Seattle. Sorry, Mao, where are you at?
I'm in Helsinki, Finland.
Awesome. Finland. That takes the prize so far from furthest away. If anyone
Right.
tuning in is further away than Finland, I guess it's all relative, to where you're at. But all right, we've got one Canada and one Austin as well. Very cool. Very cool. Well, welcome all, wherever you're tuning in from.
Okay, let's get started. Today's session is supposed to be demo focus, but since our main product is about VPS, and the VPS, we're supposed to make our main focus is actually mapping and localization for really large space. And it's a bit difficult to show on live for mapping a really large space using this computer here. I will do a live demo, but the live demo is going to be for a small room, just my living room here. But still, I will show you the whole process of starting from the mapping, and then generating the map, then building your application in Unity, and I will still demonstrate you the whole process. At the same time, in my slides, I will show you more interesting, cool stuff for larger spaces, especially for industrial use cases. So I prepare a lot of video, and inside the video, I can tell you a lot more detail about that. So today's session is going to be 2 parts. Part 1, I'm going to do some product introduction, and in the part 2, I will do a live demo. So let's get started. So about Immersal. Immersal is a company based in Helsinki, Finland, and we founded in the year 2015. And in about the 2021, and we were acquired by Hexagon. So basically, we belongs to Leica Geosystem, and Leica Geosystem belongs to Hexagon. And since the beginning, we have been focusing on developing the VPS technology, the visual positioning system. And basically, this technology allows you to do a mapping for a physical space and convert that mapping to a spatial map. And on top of the spatial map, you can develop a lot of things, including positioning, including various kind of AR, large-scale AR experience. And we provide a really accurate centimeter-level accuracy positioning for various kind of devices, including smartphone, tablets, AR glass, MR glass. And with our Immersal SDK, you can easily create a large-scale AR experience, even without a code. And our client has been spreading all over the world. Yeah, that's about us. And my slides has 2 parts. Part 1 is what. Part 2 is how. So part 1 is that I will explain to you what does Immersal offer and what do we do basically. So as I just mentioned, we developed a VPS technology, visual positioning system. Basically, this technology allows you to scan a physical space. The space can be really small, like table scale, can be really large, like city scale. Maybe some of the audience, maybe most of the audience comes from this AR, like spatial computing or AR world. Everyone knows that everything starts from markers, maybe 20 years ago. And in the beginning, we have marker-based tracking. Then we can do table scale tracking. Table scale tracking means that if you put virtual content on the table, if you move around, we can make sure that the content is just stay still there on the table. And then after ARKit, ARCore I was born, we can do room scale tracking. But today we are talking about even more. We are talking about building scale and even city scale. So basically, we can allow you to scan a large space as big as building scale or city scale level space, and then we can convert that into a spatial map. But a spatial map is actually, technically speaking, spatial map is a point cloud, or less technically speaking, it's a sparse map. Like this, for example, it's actually a collection of feature points. Where some people will ask, "Hey, this spatial map looks very sparse. It doesn't look like a real." Well, I would say that the spatial map is actually a sparse map. It's supposed to be very sparse because every single point here only represents that here there's a feature. It's only the feature points, the collection of feature points, and it's which is very different from the goal of, let's say, 3D reconstruction. In the context of 3D reconstruction, you need a very dense map because you're supposed to build a model out of it. But this spatial map, let's say sparse map, is only used for, it's not for human being. It's actually for algorithm to get localized. It's not for human being, okay? So that's why we call it sparse map. And the spatial map is the key for everything. We use spatial map for doing visual positioning. And the visual positioning is the key thing that we do in the Immersal. With visual positioning, there are a lot of use cases. And here in the right side, I only list some very typical use case. Some of them are consumer use case, some of them are industrial use case. For example, consumer use case can be building some AR experience for indoor or outdoor, AR navigation, AR for sports, and AR for tourism, which I didn't list here. And for industrial cases, usually the industrial customer doesn't care too much about eye candy. Industrial customers usually care about whether you can solve the real problem. And then that's why we provide solutions for asset management, facility management, safety insurance, and mining case or oil and gas solutions. I will explain you about more detail about every single section, which I listed here in the coming slides. So as I mentioned, VPS mainly offers you the capability to map a physical space and generate a spatial map out of it. Here we have three typical examples, three columns here. First one is a shopping mall. And this is actually one of the largest shopping malls in North Europe. And as you can see here, here below is the spatial map of this shopping mall. In total, the shopping mall has five floors. I don't remember how much square meters it has, but it's really large. We can generate one huge map out of it for this whole space. And the point here is that you can get localized anywhere inside this whole shopping mall. And the second case is another typical large space, which is a stadium, and specifically a football stadium. Yeah. We map the whole stadium, and we generate a spatial map of the whole stadium that by using this spatial map, anywhere inside the stadium in the seats area, you can get localized yourself. And the third one is the coolest. The third one is the city scale level map, where it's not for the whole city, it's only part of the city, but still you can see some places are underground, some places are underground. And it's actually quite large. It's actually not done by one go. When the mapping was not done in one go, it was stitched up from many small maps. And every time we do the mapping, we can only cover one street block, and then we stitch them up to have this. This can be considered as a small size of city scale map.
Just gonna pause there real quick. That's very cool. That the 2 floors, the underground section, Yeah, that is very cool to look at.
Yeah,
I'm
exactly.
curious, since you have such large scale areas, my main experience with mapping things are like those ones you can do in your room to like see what something looks like on your phone or whatever. But what kind of hardwares do you use to handle such large areas? I assume you don't have people with their phones walking around everywhere.
Good question. So we can support various kind of mapping method or mapping device, starting from your mobile phone, and then we can support also 360 camera and LiDAR, laser scanner. And I'll explain or more about in more detail about how do we do the mapping and what device is recommended for which type of space a bit later.
Awesome.
Sounds great.
Okay, so yeah, those three are typical, let's say, typical large space. And what do we do when we have the spatial map? When we have the spatial map, we do one thing: visual positioning. Well, how does the visual position done? So usually we only take one input, which is one single image, which means that, for example, if you are over here, you take one shot with one single image. We extract some features out of this image, then we try to compare this set of features against the spatial map to understand not only your position, but also your rotation, which means your pose. So with one single image, we can get you localized. And here's one example. Well, this one is the spatial map of a supermarket. Those small items are actually the shelves inside the supermarket. And this is what happened when you do localization. So every time, well, this is just a testing app. Every time you tap this button, you get localized from the space, and those ping points and those pink dots are actually the spatial map, or let's say the features. You can see how well the features are aligned with the actual physical content. On site, you can decide the frequency of localization. You can do every 1 second, every 2 seconds, every 5 seconds. It's totally a case by case. But when talking about positioning, maybe some people will ask, hey, I actually have heard of the positioning method, some traditional, there are a lot of traditional positioning methods such as Bluetooth beacon, Wi-Fi, geomagnetic, RFID. Yeah, there are already, indeed, there are a lot of positioning method already, but actually the visual positioning, let's say positioning using computer vision, is the most accurate one, and also it's the cheapest one, because you don't actually need to install any hardware, extra hardware like Bluetooth beacon. What you need to do is only to take a scan in the space, and also most importantly, the accuracy is the highest, so we can achieve centimeter level accuracy of the positioning. Yeah, this is the.
Sorry to interrupt. That seems really impressive to me. Centimeter level accuracy is also very cool. I can see that being very useful in creating some augmented reality experiences with some more intricate scenes. So yeah, awesome.
Yeah. Yep. Here, let me show you some typical use case from consumer. Let's say this one is a typical use case, outdoor consumer use case, and this is this is done by our customer in Times Square in New York, and they use our software, our tools to scan the whole space in the Times Square and generate a spatial map out of it. And on top of the spatial map, the user can get localized anywhere on the square, so that we can make sure the virtual content can be overlaid properly, no matter how you move in the square. And user can get localized anywhere, no matter how you walk on the square. The coverage content can maintain the correct pose. And the right side is a typical indoor case. It's in a library in Germany, and also our customer used our tools to scan the whole building and they got a spatial map of the whole building, and anyone can get localized anywhere inside the building, and so that they can place some interesting content in some point of interest. And the virtual content can be maintained, that can maintain the correct pose no matter how you move inside a space. But the point of here is not the cool content. The point is the biggest challenge is that we can support you to map such large area, and we can make sure that user can get localized anywhere inside the space. That's the most challenging work. And some people could ask that, especially some AR developer could ask, hey, maybe I can also do this, or I can also implement this with just ARKit or AR Core. Why do I need VPS? Here I need to explain this. So it is true that with our device, or probably your device, you already have SLAM tracking. For example, on iOS device, you have ARKit. On Android device, we have AR Core. On AR glasses, or maybe on, for example, on HoloLens, or on Apple Vision Pro, Oculus, you already have some SLAM tracking from your AR glass. But those SLAM tracking are mainly used for room scale tracking, or several room scale tracking. But here now we are talking about larger scale, like building scale, street block scale, or even city scale. The problem for SLAM from the device is that if you walk too much, like for example, if you walk 30 meters, 50 meters away, you're actually generating trouble to your IMU. And those trouble are some little errors from your sensors. And when those errors trying to accumulate when time goes, then what will be reflected is the sensor drift. So you will see the content are drifted away a little by little when you walk away. So that's so-called sensor drift. So VPS is supposed to be correcting the drift from SLAM tracking. So that means that without VPS, probably you can only do room scale AR experience, but not for building scale, not for city scale. For a larger scale, you need to combine SLAM tracking together with VPS. So VPS is supposed to be correcting the drift from the SLAM. So in reality, for such kind of, for example, for this kind of large-scale AR experience, usually the SLAM tracking from your device and VPS are running side by side. Both of them running side by side. The frequency is very different. The SLAM tracking is very fast, for example, 30 FPS or 60 FPS even. But VPS doesn't have to be that fast. The VPS can be every 1 second, every 2 seconds, every 5 seconds, because VPS only supposed to correct the drift from the SLAM. Even sometimes you don't actually need to do constant localization from VPS. You can do localize once and then handle everything to SLAM tracking. So that's the relationship between SLAM tracking and VPS. So the answer is the
question. So I guess just to clarify, to make sure I'm understanding you right for the audience as well. So the SLAM tracking definitely handles like the immediate what's going around you, making sure it knows where things are. But for larger scales, when you're moving around a lot, the VPS overall map helps you to make sure you stay planted in where you're supposed to be in the map to prevent any kind of drift. So regardless of where you go in a large area, you keep a good experience. Is that accurate?
Yeah, exactly. So SLAM tracking is actually dynamic. It's dynamically building the map or understanding the environment. But when you move too much, you get drift. And VPS is more like you have a static map for the whole space, which you can refer to correct the drift from the SLAM. So you need both running side by side for a large scale AR experience.
That makes sense to me. I wanted to touch back on something that you mentioned, doing the VPS every 5 seconds. Could you explain a little bit more about that? What exactly are you doing every 5 seconds?
Yeah, for example, in this Times Square case, if I do localization every 5 seconds or even 10 seconds, every time when I get localized, so basically so when you move on, your pores is mainly be maintained by SLAM tracking from your device, but the VPS is trying to get localized from the static spatial map to correct the pose of the SLAM tracking. So when you without VPS, you could be accumulating errors every single seconds, but when you after 5 seconds or 10 seconds, you get localized from VPS, you can actually correct the drift within those 5 seconds, 10 seconds.
Are those errors occurring because it's just dynamically live seeing what's around it with no map as context, but the VPS is keeping like the mapping in context? Or am I mistaken there?
But the VPS is correcting the drift every 5 seconds or 10 seconds to maintain the overall pulse is correct. But the slam tracking is still the main thing to maintain the content.
Got it.
We got a question from chat real quick. We got a bit of, they say, sorry for the noob question, but could you please tell us what SLAM and VPS stand for in this context?
Well, slam tracking is the simultaneous localization and mapping, which is very common on your mobile phone or tablets or AR glasses. Well, we are talking about 6 degree of freedom slam tracking, and VPS stands for Visual Positioning System. So basically, you can understand them that slam tracking is the dynamic map building, dynamic localization mapping, and VPS is more like a static mapping and localization, which is for reference from slam tracking.
Thanks for that, Mao, and thanks for your question. No noob questions here. Keep them coming.
Okay. Yeah, let's continue. Another typical use case is the AR navigation. So, of course, since we can do positioning, then the typical use case is that we can provide navigation or wayfinding. And then the navigation can be provided in 2 ways. One is that when you get localized, we can show you the position on your 2D screen like this. Another way is that we can show you the exact side in the 3D, in the camera view in 3D like this, like the right side. Yeah, indoor navigation is very typical use case for everything. Or let's say for user experience, actually indoor navigation or positioning is the basis for everything. For different scenario, it can be different. For example, for shopping mall, it can be the one who can guide you to the shop which you have discount. For hospitals, it can be the navigation or guidance for patients to reach the doctor's room or doing inspections. And for maintenance case, it's a different case. Basically, navigation is the basis for it's the infrastructure or basis for everything. And here there's this is the AR for sports. This is more interesting, and as you can see that this is very challenging space. This is a stadium, and a stadium is usually considered as a typical large space, which is really challenging because it's very large. This is a baseball stadium, and our customer has used our tool to map the whole space, and so that the user can get localized anywhere in the seats area. And when you get localized, you can see this kind of visualization, which shows you the trajectory, how the ball goes, and what is the direction, and how hard it hits. This kind of visualization, it's really cool. But the point here is not the cool visualization. The point here is that we can support you to map such large area, such as the whole stadium. And within this large area, you can get localized anywhere within the stadium, so that you can see the correct.
Got a question on this one. I understand that you can map using your technology the entire stadium, but
Right.
How do you position the individual players within the stadium, since those come probably after the initial scan is done?
Yeah. So the data, actually, for this case, we integrated the data from some IoT system, which provides the ball tracking and player tracking. So basically, we get those data, and we visualize them on site. But if you want to make sure that those data are the VPS, the positioning is the key method to make sure the data are presented in the correct place.
Okay, I see.
Yeah. Okay. And also, of course, in the sports stadium, you can also play some cool content, such as this volumetric video of a cool player. football player. And AR for sports is actually a very interesting topic that on top of this positioning and localization, you can also place not only this kind of visualization, but also, for example, some billboards or advertisement, or even some small games, interactive game, to engage the customers on site. And this is a typical industrial cases, which is so-called asset management or facility management. And this one is used for building maintenance use case. And well, the maintenance engineer, when the maintenance engineer come over, he or she got the list of the maintenance task, which is a drop-down list. And by clicking one of the maintenance tasks, he or she can start start localization. So this customer, they map the whole building with our technology, and anywhere, and maintenance engineers can get localized anywhere inside the building. And when you start and basically there's a navigation robot which can lead you to the problematic place. After you fix that, you can also place a virtual tag or virtual nodes there. Also, you can check the virtual nodes which is left by the last maintenance engineer. So the point here is that we can support to map the whole building out of it. And in a way, you can also visualize the pipes behind the ceiling or behind the wall, which actually comes from the beam model. Yeah, the right side is a typical example for tagging. Because for industrial cases, usually probably you already have some sort of digital twin system, and you want to understand which is what. And by tagging, it's possible for you to see which is what on site in the AR view. And this is typical. This is another typical example of industrial use case. Because for industrial use case, sometimes the positioning is not for people, but more like for robot or vehicle. And this is one example that, well, this is not for a robot, but this one is from this. The positioning of this demo is from body cam, which you wear in front of your chest. And yeah, and this the similar use case can be applied on the robot dog, for example, and also the vehicle, and also some machines in the mining cave, for example. So basically, any device can be supported to get localized from the spatial map. So it's not only smartphone, it's not only smartphone or AR glasses, but basically any camera, because with one single image, we can get localized from the spatial map.
I find this really cool in this part, because like, you know, when you have like GPS that can get you over all the general places, but once you get to that fine-tuned area, you're in a really big building, it's kind of hard to find where you got to go. But being able to have these 3D recreated environments, you can have within a centimeter of accuracy of where you're trying to go to, and then being able to add all these extra details of some tagging if you're in the more industrial use case, to have some notes to know where things are, or see-through walls for where the pipes are. It's super cool to see the potential of all the areas this can influence in there.
Yeah. This is indoor space. There's no GPS at all, so you have to rely on something more accurate.
Yeah. Instead of GPS, when you're the closer in, this is the equivalent of getting you around, is what I meant.
Yeah. And here's a typical mining case. And so for mining case, it's another place where you don't have GPS at all, and VPS is actually a very good choice for you to get localized in this case. It's sometimes very dark and it's lack of features, and there's no GPS in signal, and spatial and computer vision is the best method for positioning, not only for people but also for vehicles, for machines, for robot dog in this kind of environment. You can see it for mining cave. As a human being, we think we tend to think that it's lack of feature, but actually it has a lot of feature inside. So the tracking quality is actually quite good. And this is a typical another industrial cases. For example, on some oil and gas places, which is full of machine, and we can also do localization as well as navigation, and also some typical use cases: asset management, facility management. And another interesting use case is that usually this kind of customer, they already have digital twin system, which means that you already have a bunch of 3D map model, and probably you also have the needs to place or tag 3D digital twin assets back to the physical space, so that the worker can understand on site which machine is what. For example, this is a tank, this is a Peter, which is what. And the spatial mapping allows you to map the digital assets to the physical site, and at the same time provide you the navigation like this. Also, there were some use cases like safety insurance. For example, for some dangerous zone, we can show some virtual fence, which can tell you that don't go there, kind of like that. Okay, basically that's what part. So now let's talk about how the mapping was done. So as I just mentioned, the mapping can be done in various kind of method. For example, you can do the mapping with a mobile phone or tablets. You can do the mapping with 360 camera, and also you can do the mapping with laser scanner or LiDAR. And we have a centralized REST API, which allows you to upload the input for map construction to generate a spatial map. So no matter which method that you're using, no matter you are doing the mapping with mobile phone or a 360 camera or laser scanner or whatever, the input are the same. The input are the images and camera pose. So input are the same. So we use images plus camera pose. That's also what the REST API receive. The REST API receive images plus camera pose for map construction. After that, you have the spatial map, which is a point cloud, which is a sparse point cloud like this. And also we generate a dense map with texture like this. Where the sparse map is used for machine, or let's say for algorithm to get localized, it's not for human being. At the same time, this dense map with texture is for human being to understand which is what. This is mainly for development purpose, because from this one you can tell which is what, so that you can decide what kind of virtual content to put, where to put this virtual content, and what kind of interaction you want to develop it with.
Really quickly, do you see one method working better than another method typically, or does it really depend on the execution of the person taking the footage?
Yeah, I mean the mapping method.
Exactly. Yeah.
Yeah, usually the mapping method, there's no, the devices, the price of the device are very different. For example, this mobile phone, cheap camera, 360 camera, we are talking about consumer level 360 camera, which is also very cheap, like 500 or 600 US dollar. But the LiDAR is super expensive. It's not the way that the more expensive device is better. It's not always like that. Sometimes for example, for some stadium case, we didn't do the mapping with laser scanner. For stadium case, we did the mapping only with the mobile phone. And because we want to make sure that we only collect image towards the center, towards the field. And if you do the mapping with 360 camera or LiDAR, probably can't control where you shoot. So it really depends, really case by case. But in general, the advantage of LiDAR or laser scanner is that a laser scanner have really reliable and accurate SLAM tracking by itself. That means the camera pose from laser scanner is very reliable and accurate. As I mentioned, no matter which method you are using, the input for map construction is the same, images and camera pose. Well, the images totally depends on the quality of the camera, right? The quality of the camera pose is totally dependent on the SLAM tracking of the device itself. With the SLAM tracking of the mobile phone comes from your AR kit or AR core, but the slam tracking from laser scanner is really accurate and reliable. So
when you
that's
say that it can be more reliable with the LiDARs, like how different, I guess, would that, since you did do one industry-wise with the phone case for the stadium, I'm curious, like, does that just mean that kind of use case would be more likely to have a drop or something? Or is there just like software in the back end to help make up for that if that happens? Maybe like checks your overall location more frequently or something?
sorry, I didn't understand, get your question.
Gotcha. So you said that the LiDARs are more reliable,
Yeah.
was one phrasing you said. I'm curious how that reliability looks like in the real world, I guess, compared to, like, say, using the smartphone.
Yeah. Compare, for example, this is the same situation as I mentioned. So with your mobile phone, you have problem from the slam tracking. The problem is the sensor drift from ARKit or ARCore. If you walk too far away, like more than 50 meters, 60 meters away, you are starting to generate troubles from your IMU, and the camera pulse from your mobile phone is not going to be reliable anymore when you walk too much. But at the same time, if you're doing the mapping with LiDAR, because the LiDAR also have slam tracking, but it's laser-based slam tracking, which can be still very reliable when you walk too much, like 50 meters or even to 100 meters. It can still maintain a very good camera pose.
Then I guess one clarification I'm trying to make is the LiDAR in the phone, is that being used for the initial scan of the overall large area and whenever you're using it? So I guess like a robot would use a LiDAR while it's moving, or is it just for the sake of the mapping in the first place, or is it for the live mapping while you're moving, I guess? I did see on your site that you have a drone and I believe a robot dog on one of them. Are those used to do the scanning in the first place, that then others can come in and use either a phone or another method to navigate around, if that makes more sense?
Yeah, now we are only talking about mapping methods. I mean, the mapping with the mobile phone or with camera or LiDAR. And even drone can be used for mapping, but drone might be not a good choice unless you want to provide the perspective from the drone's perspective. Because another important mapping, let's say, guideline is that when doing the mapping, we have to make sure the pulse from the mapping is always aligned to the localization time from the user. So that's why sometimes most of the time the drone is not a good choice, because the drone does the mapping from the sky. But as a user, I don't use my phone. I don't do my AR experience from the sky. I do it from the ground. So it's from different perspective. Yeah. Anyway, I'll explain more detail about this mapping method a bit later. So basically, we can do the mapping with various kind of methods, and when you generate a spatial map, and you have the dense map generated as well. And here, this slide shows how is the app development process. When you have the spatial map, you can move around in the space, and to test the map, basically you need to test. You need to go around the space to test if you can successfully get localized anywhere. Do we have any corner which you cannot get localized? And when you think everything's fine, when you consider the map is in good quality, then you can start placing virtual content on top of the spatial map. And after the application is built, you can have the virtual content in place like this. You don't see the virtual in the final content in the final application. Probably you don't see the point cloud like this, but actually the tracking is happening every 1 second or every few seconds in the background. Okay, this is a technical overview which has more information about the mapping method. than the previous slides. As we can see, the first row shows what kind of mapping method we can support. The second row shows what kind of localization client that we can support. For the mapping method, we can basically 3 categories: mobile phone, tablets, 360 camera, or laser scanner or LiDAR. And with mobile phone, we provide an official application called Immersal Mapper. And also we can support you to do the mapping with some third-party software such as Polycam or 3D scanner app. And we can export their raw data, which is images plus camera pose, and use those images and camera pose for map construction. And 360 camera is very special. It's very special because 360 camera does not have SLAM tracking. So as I mentioned, that mobile phone, you have SLAM tracking from your AR kit or your core. LiDAR, you also have SLAM tracking, which is very reliable and accurate, which is laser SLAM. But for a 360 camera, you don't have SLAM at all because this is just a camera. And for a 360 camera, you have to run SFM, structure from motion pipeline, which is for evaluating the camera pose from the bunch of images, and use that camera pose to map construction, which is good. But comparing to laser scanner or LiDAR, the camera pose for 360 camera is evaluated from the algorithm, which is usually not as accurate and reliable as laser scanner or LiDAR, let's say. So yeah, but still we can support those multiple methods that you can choose depending on the type of your space.
I got a quick question from the audience if you got a sec. Blue Egg asks, I noticed you had a sample for X-Real Lite. Is X-Real Ultra also supported, or is it planned to be by chance?
It's in our plan at this moment. I think you are talking about X-Real Ultra, X-Real Air 2 Ultra, right? Which supports 6-DoF SLAM tracking. That's in our plan. Yeah, if we take a look at the device that we can support for localization, here in the bottom left are basically mobile phones, the iOS devices, Android devices, Huawei devices, and Magic Leap HoloLens are the most popular industrial AR glasses, and X-Ray Lite, Rocket are typical consumer AR glasses, and this Vision Pro, Pico, they are the typical AMR headset, which can be also supported. And the last category is web AR. The web AR is, there are two types. One is the browser-based web AR, another is widget. The browser-based web AR we can be combined with 8th wall or Zapper. Well, the point here to use 8th wall or Zapper is that we use the SLAM tracking, web SLAM tracking from 8th wall or Zapper. In combined with those, in combined with 8th wall, in combined with the SLAM tracking from 8th wall or Zapper, you can do good web AR experience. And another thing I wanted to point out here is that for localization, we can support both on-device localization and on-server localization. Well, the difference is that for on-device localization, the computing of the localization happens on the device, whereas for on-server localization, this happens on the server. This is actually very different in practice. Well, let's say, technically speaking, the advantage of on-server localization is that we can make sure the user experience is the same among different type of device, no matter it's an old Android phone or the latest iPhone 16 Pro. Because what I should do is very simple. I just send one request, which is I just send one image to the server, and the server does the computing, does the localization, and then come back to me with the result, which is the pose. So the hard job is done on the server, and what has to be done on the device is very simple. So that's why I can make sure the user experience is the same among different type of device, no matter what kind of computing power you have on your device. However, the downside of on-server localization is that the number of users that can do this thing in parallel is limited, depending on your bandwidth, depending on how strong your server is, depending on, let's say, how much money you pay, because it has a cost on the server. It's expensive, let's say. It's technically expensive, and it's money-wise, it's also very expensive. Whereas on the other side, for on-device localization, it's very flexible, it's very lightweight, because the localization, the computing happens on the device. However, the user experience could be very different. It totally depends on how powerful your device is. It totally depends on the computing capability of your device. If the worst case is that you have a really large map, and your device is very low end, for example, some old Android phone, then simply for loading the map and doing the localization could take a few seconds, which is bad. Yeah, so that's why for on-device localization, it's very flexible. It's offline. It's totally offline. You don't have to connect to your server, but the user experience could be different, very different. But usually for some cases, for example, for a museum or for some industrial cases, where if you can decide which device you use, you can properly control this performance issue, still using on-device localization.
Yeah, it's really interesting to hear the trade-offs of the two there. So with on-device, an unlimited amount of users can share in the same experience. Did I hear that correctly?
Right.
Gotcha. Okay.
I am curious on like a typical, because like you said, HoloLens is one of the pretty popular ones they use. For the amount of space those typically have, are they able to hold on device a map as large as a whole stadium? Or was there like a certain limit at a certain point that's pretty standard for what they can typically hold? I was curious about that.
Yeah, good question. For a stadium case, usually the map is a bit large. For HoloLens 1, maybe a bit challenging. For 2, maybe possible. Also depends on how well you do the map optimization. We have a bunch of methods which allows you to optimize the map, let's say, to be as lightweight as possible. And also there are some tricks to kind of like dividing a huge map into multiple sections and dynamically loading only one section out of it, which is some kind of like a trick for using large map in a space. Which means that if your device is really low end, you have to on the same time your project is for really large space, you have to do some trick for like that.
Okay, interesting. Good to know.
Yeah. Is there any more question about this?
Like we're good for now?
Okay, yeah. So before we dive into the live demo, this is the last table that which shows the spatial part from Immersal. So basically, at Immersal, we try to offer a flexible and professional toolbox instead of a black box for developer. The black box means we try to encapsulate everything and hide some detail in the background. No, but more like trying to provide a toolbox which provides you the possibilities. You can decide what tools to use, and it's very flexible. So our Spatial, there are 4 aspects. So for mapping, we can support multiple mapping methods, like I mentioned, starting from mobile phone to 360 camera to laser scanner. And for localization, you can do on-device localization. Also, you can do on-server localization. And also, our SDK is very open. We never try to encapsulate the camera components, which means that when using Immersal SDK, you can also combine it with some third-party AR SDK, for example, Vuforia or because we are totally compatible with AR Foundation. And it's quite open. And also we provide a REST API, which allows you to easily integrate the mapping and localization from any of your device, any other device, which is not officially supported. For example, if you say, hey, I want to do a mapping with a Logitech camera or my own camera, it's possible. Or let's say, hey, I want to use Immersal with new AR glasses or with my camera, with my survey camera in the factory, which is also possible. So because we are using this, we'll provide this REST API, which is very flexible for you to build your own customized solution. And the last part is that for deployment, we can support, where we have our production server, which is by default running on AWS and for everyone. But also at the same time, especially for industrial users who are usually very concerned about data security, we also provide the possibility to develop and deploy the server on site, on premise. And we can support private deployment so that all the data can be maintained on your own server and to ensure the data security. Yeah, that's the special part from Immersal.
Awesome. We love to hear the AWS servers are the default, +1 there. But on premises, yeah, we definitely see in spatial computing a lot of customers that want to keep things under wraps, whether it's in their own cloud environment or on-premises environment. So very good to hear that you support that as well. Before we move on to the live demo, which I know everyone wants to see the live demo, of course, I had a question about localization. So does the localization still work offline without some kind of network or internet connection?
Right. Since we support both on-device localization and on-server localization. But the on-device localization means that the localization happens on the device. It's totally offline. So what you can do is that you can embed the map into the application so that even the map does not have to be downloaded from the server. It's totally offline. You can embed a map into the application, and the localization happens also fully on the device. That's possible.
Awesome. Yeah, that's great to hear.
Yeah. Okay. If we don't have any other question, we can move on to the live demo.
Fantastic. As we move on to the live demo, we're about an hour in. If you're just joining, welcome. This is our weekly Howdy Partner series here on the AWS Twitch channel, where we showcase very cool partners. And this week we have Immersal showing us their VPS technology and how that can lead to some really, really cool augmented reality experiences.
Okay, let's move on for live demo. So what I want to show you is the whole process of building one single simple AR experience by using Immersal sample. Okay. So in the beginning, if I open up Immersal, if you go to immersal.com, here you can see the link of developer portal. So there are two servers. International server is the default server that we use. If you go to international server, this is the Immersal developer portal. And if you log in, this is where you manage all your maps. Okay. And each row is one map. For example, here I have, let me show you some typical map over here. For example, this is one map of our table tennis building. And within this view, you can also visualize the camera pose. Can you see this? Off,
Yes.
off, on. So the camera pose represents your pose when you do the scanning. So if we zoom in, we can see that each one is like this, which represents that it has 6 images towards 6 directions, because this one was done with a 360 camera, and one panorama image is usually divided into 6 not pinhole images. That's why it has 6 direction. So basically, each one of them represents the pose when you do the mapping. You see, there are a lot of dots, which means there are a lot of images for generating this map. Okay, but yeah, that's an existing map. I'm not going to use that for the live demo, so I would do something from the scratch. I will try to map my living room over here, which, let me show you if you can see my screen. I will try to map this living room over here, and then generate the spatial map, and on top of the spatial map, I will build an app out of it. So let's do that. So in the beginning, what I want to do is that I want to find out Immersal Mapper. I have already installed it. It's called Immersal Mapper. It's called Mapper, simply. So when you open up Immersal Mapper, you can click this plus button to start mapping. I have to grab my camera, grab my laptop together with me. So if you take a look at the up right corner, there are 2 buttons there. One is M, one is R. M represents manual mode. R represents real-time mode. Usually what I do is to use the manual mode. If I use real-time mode, well, yeah, the default mode is real-time mode. Is very user-friendly for beginners. The real-time mode means that you can shoot video, and the manual mode, usually you take pictures. So if I use the real-time mode here, I click start, then I can start mapping my space. You can see the point cloud is generated on the go. When I move, I have to make sure that every 2, so maybe you can't see it, but I can feel the vibration from my phone, which represents every single scan. So even though I'm shooting a video app, but actually is taking pictures every 1 second, I have to make sure that I move slowly so that every other image, they have enough overlapping. This is very important, especially when you use manual mode for the mapping.
I think we lost the screen share.
Yeah, Matt, I think we lost the screen share. If you want to finish the map, and then we'll bring the screen share back on, whatever works best.
Can you see my screen?
Not at the moment, no.
Okay.
Yeah.
This now. Let me return my sharing. Sorry about that.
Nope, no worries. We are live and scrappy here at HP.
Yeah, hope.
Yeah,
we got you back.
Yep, we're back on.
Okay. Okay. So after the mapping, I can tap the name like and save the map. And you want to upload the data to the server. Okay, then if you go back to Immersal's backend, you see there's a map over there, like this. Okay. However, if you do the mapping with real-time mode, you would only have this spatial map. You only have this sparse map generated, but you don't have dense map. So that's why. But anyway.
Sorry, just want to loop back on that. So if you do real-time mode, you only get the sparse map. But if you do manual mode, where you're taking the pictures, you'll also get a dense map as well.
Right.
Gotcha.
Right.
How many pictures does it typically take if you're doing it in the manual mode? Since you said the real time was doing it every second, so I'm sure that took a whole bunch of pictures. Do you just kind of rapid fire it as you go by in the manual, or is it a bit slower?
Let me show you. Let me show you the mapping with the. Let me show you the mapping with the manual mode over here. So if I do the mapping with the manual mode, usually it's done like this. So I take a lot of pictures. 1, 2, 3. You have to make sure that every other image has enough overlapping. And at least you need to take like 20 images, I would say, at least. But for this room, maybe a lot more, maybe 50 images at least, or even 60 images or 90 images. Because when you move, you have to make sure that every other image has enough overlapping. And also, most importantly, when you do the mapping, you have to consider where the user wants to stand and towards which direction the user might wants to put their phone. So basically, you want to simulate the user's pose, or let's say user's perspective. You want to make sure that the pose from the mapping is aligned to the pose from the user when doing localization time.
So what is it about doing it manual versus through the recording that makes it where it can or it does or does not add that more dense map instead of just the sparse, I believe was the
No, that's not the main point. The point of the manual modes is that it's very flexible, and because I can just walk over to another place. For example, I can walk over to here just to complement some images. I can pause the mapping. I can walk over to another place and restart, just adding more images. So it's very flexible. And we use this method. We actually use this mapping method for mapping for a large space like stadium, because we can make sure which direction we take to shoot the images. After then, you can just save the images. And upload it. So then it will upload all the images to the server and trigger a map construction. Okay, which could take a while, but it doesn't matter. So let's continue for the development. So then, as a developer, you should come over to this, the main page of the developer portal. And you should focus on the 2.0 beta SDK. And when you click that link, you come to this 2.0 beta and getting started document. You should go to this getting started document. By following this document, I need to create one empty project in Unity. Let's do that. Let's create one new project, just this default 3D project, and rename it as, for example, AWS demo. I need to change my location. Okay, let's create it. Just create one simple empty project, and then we shall install the Immersal SDK through Windows. The Unity Package Manager. And coming back to this tutorial, we should copy this package URL over here. Let's copy this here, and later on we should paste it in Unity. So when I open up Unity, see this is just an empty project. I should come to this package manager and click this add package git URL and paste it. Click add. Then start to download the SDK package.
While that's downloading, Mao, looks like we got some questions in the chat here.
Yeah.
First is, what do you think is the biggest blocker to more AR adoption in the industry?
What kind of blocker?
What do you think is keeping maybe augmented reality from really taking off?
Yeah,
it seems like the
right.
technology is getting there, but the adoption is still maybe lagging a bit behind.
Good question. So from my point of view, we can see, I have been handling this customer cases globally from all sorts, all type of companies, all type of use cases. But most use cases, let's say, are still more like an experience, only experience. Like, for example, AR for museum, AR for tourism, AR for here, AR for that, but most of them are just for viewing something, or very few interaction. Even if you have interaction, it's more like entertainment purpose, let's say. So, so the key thing here is that whether you can solve real problem, where there can be some hard problem, which has to be solved with AR. So if you find out that can make really the AR experience to be mandatory, let's say. And we have been seeking this kind of use case, especially in this industrial use case. For example, we have been looking into this oil and gas and refinery, asset management, facilities management, all sorts of industrial cases, trying to solve the real problem, not only just providing eye candies. That's the key thing.
Yeah, I think that's a great point. Yeah, a lot of these AR apps are like cool, but they're not really, it's just entertainment. And
right.
That's really where I think AR differs from VR, because VR as well, I find it to be a little more on the entertainment side, maybe the gaming side, and augmented reality has the ability to really help with practical usage. So really excited to see more applications come out, so that way we can really start using this. Right. Also the glasses as well. Once we get those glasses to a form factor that's lightweight but can do full AR, I think it's game over personally. I think almost everybody might be using it.
Yeah. Good question.
Yep, we've got a few more. We will ask those, but we'll go ahead with the demo just a little bit more here, and then we'll get some of those questions in. Keep them coming. Thanks for asking, everyone.
Yep. So when the SDK got installed, it will automatically restart your Unity because basically it wants to change the rendering pipeline to URP. Well, it doesn't require URP, but we suggest to use URP in our sample.
And what is URP? Sorry, I might have missed that.
The new rendering pipeline, universal rendering pipeline.
Got it.
So when you come back, and then you need to click this. Sometimes this you need to click this Immersal SDK project validation to fix some issue. You just click this button to fix all the issues. And then if you come back to this package manager, find out Immersal SDK. Also, please install this samples. Samples is in a different package from the SDK. So after that, you get, if you take a look at this project hierarchy, we've got this samples, Immersal SDK 2.0, 2.3, and core samples. If you expand it, you can see there's a sceneness. And the sceneness, those are the typical immersive samples for you. Just an explanation, what we usually do is to get, what we recommend usually to get started is this multi-map sample. And multi-map sample means that you can simply get localized from one map or multiple map. And you click, if you click that, well, this is just for some texture, some text components. And this is a very simple one. And another cool sample, which is another popular sample, is this navigation. Well, there are two navigation. One is navigation sample graph. Another one is navigation sample nav mesh. The latter one is the one we will try today. So actually, both the multi-map sample and navigation sample, they share the same parts, which is the basis of doing localization. So I would not, to save time, I would not start with the multi-map sample, but I would directly go with the navigation sample. But in the beginning, I would not build a navigation experience. I would just show some, I would just overlay some simple static content first. So if we click this, well, now we open this navigation sample nav mesh. To begin with, let's save this scene to a new scene, like for example, AWS demo. Okay, let's see what we have now. What we have here. So this direct light, there's nothing to be explained. It's just a default lighting components from Unity. AR session from AR Foundation. We don't need to touch. AR XR region is the camera components from AR Foundation. We don't need to touch. And event system, we don't need to touch. This is the event system from Unity. And this Immersal SDK, this is the key part from Immersal. And if you select this on the right side, you see you need to make sure that you put your developer token here. And also you have to make sure you choose the right server. The default server is what we use, which is the international server. But it's recommended you to go to Immersal SDK and press log in. This will, when you log in, you will automatically fill the developer token for you. For example, if I do login over here, oops. Okay, got it. So you see the developer token is automatically filled. And under this, we don't need to change anything. Basically, there are a few Immersal components. For example, this one allows you to customize the frequency of localization, which is set to 2 seconds by default, which is this session updates interval. And you can put 2 or 1 or 5. This represents how much seconds you want to do localization. And you don't need to change anything over here. And this canvas and the UI are basically the user interface. We don't need to change anything over here. And this generate nave mesh surface. This is something that we need to generate the nave mesh map later. But at this moment, we can just clear the default one because this is a default one which doesn't work for my space. So what I want to do now is that I expand this XR space, and I can see that under this XR space there are 3 maps over here, A, B, and C, right? You can see there are 3 different colors, pink, green, and blue. Those are 3 maps in your office, which you cannot use. You have to replace those 3 maps with your map. And just one explanation for this XR space. XR space is the key thing that you put your virtual content. So you should put all the virtual content under this XR space components. And XR space is the one which will be managed by Immersal SDK, which means that every time when we get localized, Immersal SDK is going to manipulate the pose of XR space to make sure the virtual content is overlaid in the correct pose on top of the physical space. So when you put virtual content under this XR space, the virtual content is managed by Immersal. If you put it outside, it's not. It will be always stay there. So now we want to.
Yes, really quick. This might be a good time to ask the next audience question. I see because there are a lot of dots there on the screen. The question is: are those individual dots that are placed by LiDAR? Are they detecting which angle the images are placed, or are they just stacking to draw vertical versus horizontal?
Those dots, I mean, the dots on the screen.
Yeah.
Those dots are actually the spatial map, or sample spatial map, let's say. So now we need to replace those sample map with our own map. And each dot represents one feature of the map.
Got it. And then but those features do detect which angle that feature was shot at. Is that right?
Not really. Those dots only represents that at this point there's a feature, but it doesn't tell you the camera pose for getting this feature.
Got it. Okay.
Okay. So now we don't need 3 maps. We can just delete 2 of them and leave only 1 here and replace this left one with our own map. What we want to do is that we want to reconfigure map. And here on this screen, I can place the map ID of my map. I have a better map generated before the meeting.
Also, quick follow-up on that last question from one of the viewers. They said, I guess what they're trying to ask is what are the data points those dots represent, if anything? And someone else asked, is it a cloud of points?
What was the question about? So what does it mean for each dots?
So what they're trying to ask is what are the data points those dots represent, if anything? If they're not like the angle of the camera, like, and you say it's a feature, I guess it's like what data point, if any, is it representing, I guess?
Yeah, basically it represents every single dot here represents that in this position there's a feature. For example, just imagine if you have a checkerboard on the ground, you will see that the dots are appeared mainly on the corner of each checkerboard, each grid, let's say. So those dots represents that here there's a feature in the space.
And
A
does that
feature, do you
mean-
mean like an object? Like a group of features would like wrap around a wall if you saw a wall type thing?
Basically, the feature means that, for example, there are some radical color change, or for example, if a table, the four corner of the table can have could be the place which will have some feature. If you have a wallpaper on the wall, let's say if you have a white wall, and on the white wall you don't have a wallpaper hanging on the wall, and probably you only get some feature from the wallpaper. And then you only see the points from the wallpaper. Does that answer your question?
Yeah, that makes sense. So those features are pretty much, those are points that you'd probably want to overlay some kind of AR content. Is that
right?
Yeah, got it.
Yeah. Okay, and now we have downloaded the map into Unity, as you can see. However, in this sample, there's a floor plan object over here, which we don't want to use because this floor plan is not aligned with my space. This is just for the sample map. I should delete it. And also, what I want to, because the map is a bit difficult to see which is what. I can understand, okay, this is my table, but it's still a bit difficult to understand which is what. So I would like to also import the 3D model. So with Immersal, with the map, we can also generate a dense map as well as a GOB file. For example, this is a GOB file, or that's the 3D model of my room, of my living room. I also want to import this model into Unity. So what I want to do here is that I downloaded the GOB model. You can download the GOB model over here. Click this dot and download GOB. Then you get this GOB file over here. I already downloaded here, and I want to import it. I want to import it into Unity project. So what I want to do here is that I'll go to my Unity project. I want to add one folder, models, put my GOB file over here. But then this GOB, the GOB format is not supported by default. I have to install another open source tool to support viewing GOB file, which is this one, so-called Unity GLT Fast. So this is a draft document of this is actually Unity embedded to Unity official tool. And what we can do is that we need to install it. Let me copy the name of this package. And here we search by name. And with these components, we can visualize the GOT format 3D model. So it's done. So now if I come back to my Unity project, if I expand these models, and if I drag this GOB file into XR space, I should be able to see this. Okay, this is the 3D model of my living room, and it is aligned with the point cloud. It's aligned with the spatial map of my space. In the spatial map, I can adjust the size of the point, you can see. And from here, I can see that the point cloud is aligned with the 3D model. So that means we are good to go. We are ready to put some virtual content on the space. Okay, what I want to do here is that I want to yeah, I want to put one virtual content on top of my sofa. I have a robot model over here, prepared over here, which is this one. I will copy over into my Unity project. I have a reindeer robot model over here. I will just drag this prefab to also under XR space. See, by default it's very large. I need to scale it down. And put it to my sofa. Let me use my mouse. Okay. Okay. And also, so then when I open up the camera, I should be able to see this little guy sitting on top of my sofa. And also I would like to build the navigation. You can see there are two navigation target over here, but at this moment I don't want to change it. To build a navigation, I need to define what this floor plan look like. Do you remember that I already delete the floor plan file because that floor plan is not aligned with my space? I have to develop another, I have to make another simple model for my room as the floor plan of my room, which I already prepared over here. I have a floor plan model, which is simply a bunch of simple plane. Let me put it here and drag it into the XR space. However, this floor plan I need to adjust its pose to make sure it's aligned with my new map. Just to adjust it a little bit. So in practice, you would like to draw or make a simple floor plan by referring to this GLB file or 3D model of your space. And since I want to use nave mesh, so I also want to define a layer for this floor plan. For example, if I add a layer called navigation, because then I can only generate the nave mesh model only for the object in this navigation layer. So now if I choose this bake button, I need to choose this. I need to choose the layer to be included for generating the nave mesh. And also I need to adjust the size of the radius of the person. Okay. If I disable the 3D model, you can see this is floor plan that I made, which is aligned to my physical space. And out of it, I built a nave mesh map out of it. So the the blue nave mesh map allows the algorithm to generate the shortest path according to where you are to the target, to the navigation target. But in this sample, there are only 2 navigation targets, which is this one and this one. I need to place them to the place where I want. Again, let me place one over here in the kitchen and rename it to maybe kitchen. And another one over here, maybe put it like entrance. Maybe another one over here. Let's call it stairwell. Okay. So we have 3 navigation destination and 1 virtual guy over here on top of my sofa. And let me see, do I miss anything? Then we would like to also enable the occlusion manager so that the user experience, so that we can have occlusion. So yeah, that's all that I need. So now I didn't write a single code, so I just drag and drop some components into the space. And now let's build this app. Let's add this scene, switch the platform to iOS. We need to fix, especially we need to add this ARKit support. And now we can build the Xcode project. Let's make a folder named build iOS. Go. So we will build an Xcode project, and then we will need to open up Xcode and build to my phone.
Yeah, we had one comment in the chat saying, imagine if AI filled in all these details and more. Well, that does bring an interesting point that I was kind of curious of. It's like, since you've been involved with the industry a lot, have you noticed noticed even more so different automation techniques that have kind of come into play that have overall helped the industry, similar to just having your phone to map your surroundings instead of having to redesign a whole map from scratch? Any other interesting developments you've maybe seen in the industry?
Not really got what the question is mentioned about.
I'm just curious, different little automation things that help a lot. There's so many moving parts in a lot of VR stuff now, or in spatial computing in general, for augmented.
Yeah, we can suppose to do remote testing for automation if you're talking about automation, but not too much automation for building the map, for example, building the application. Okay, so then we have opened the Xcode project, and let's build it.
Looks like we got 15 minutes left. So if you've got any questions that you've yet to ask, please jump in there and ask away. And if you can't get the questions answered now, feel free to reach out to myself, Eli, or Mao, and we'll be happy to answer offline. Mao, do you see any device that people are using more than others? Like, are people, are your customers using this more on their phones, on headsets? Do you have any intel there about what you're seeing with your customers?
Yeah, good question. Usually for this, usually for consumer cases, usually it's supposed to support the devices from the consumer. We see that, well, from our experience, the most stable one is still ARKit's iOS devices, ARKit's devices, and especially for demo purpose, for example, usually ARKit, an iPad could be very typical, good choice. But one trend now is that there are more and more MR headsets to be supported, especially starting from Oculus Quest, now Apple Vision Pro, and also Pico. And this MR headset has very good user experience. It has a very wide field of view, and it's kind of interesting to support. So yeah, the application is built. If I can open it and show you how it goes. Oops. Oh, I forgot to remove this panel, but it doesn't matter. If I can try the navigation, works pretty well. So if I go over here, this is the stairwell destination. And also we have this little guy sitting on top of the sofa. And there's another destination over there, the kitchen. So whenever, no matter what I move, no matter how I move, it can calculate the shortest path towards the destination. So if I walk over here, the destination, the navigation path just automatically changed according to where I'm at.
Yeah, that's really cool. So it's detecting where those features are, and it's moving around those features to get to your navigation point.
Yeah.
Yeah, that's awesome. That seems like pretty quick and easy way to get a navigation app going. Honestly, I would have thought that there's a lot more complexity there, but we just did it in about 20 minutes. So it's very cool.
Yeah, if I can explain you a little bit more about this tracking part. Once again, if you take a look at the two numbers in the top right corner, the second number represents how many times of localization that we do. You can see the number grows every 2 seconds. That's because the setting of that is that we do localization every 2 seconds. And the first number represents how many times we successfully get localized from the environment. So if you walk in the space, if you take a walk in the space, you should always see the second number get growing, but maybe not the first number. Sometimes the first number get growing. That means you can well get localized. Sometimes it doesn't grow. That means at that position, you cannot get localized. That's the place which you probably want to fix. Probably want to generate a better map for that corner. Yeah, this is how we test the map quality. And also this is how the localization happens in the large space. Well, my room is not really a large space, but just to show you the idea.
Gotcha. And for the floor plan panel, do you delete that before you publish the application, or do you kind of move it below the sort of zero?
The floor plan, I supposed to remove it, totally remove it. I've just forgot to remove this game object. Yeah, it's supposed to be removed.
So you initially created just to kind of set those navigation points to help as a reference, but then you go ahead and delete it before building the application.
Yeah, the green floor plan is this one, which is supposed to be disabled when I build the app.
Got
like
it.
this.
Oh, so just disabled from view, but it's still there.
Yeah, if I disable it, we should not be seeing that. If I can, let me see if we have time to build a game. Let's do that.
While that's happening, we got a question from the audience. So is that how you put the details together with the objects? You just use a video to overlay with the map?
Yeah, what do you mean by detail?
Yeah, sorry. If you can clarify your question there, we'll definitely get it answered for you. Let's see. So that's how you put details together with the objects. Are you talking about, just going to the audience here, maybe overlaying actual content into the scene? I believe that, correct me if I'm wrong from the audience there, but maybe that's what they're asking.
Basically, you can put whatever content you want into this Excel space. And for example, in one of the demo which I showed previously, we put a volumetric video, which can be which was recorded separately. Basically, you can put whatever content, whatever 3D model or animation. It can be in very detail. It can be in high quality.
So when you created a navigation app, was that just like a preset for demo purposes, or is there a logical difference between navigation applications versus, maybe the stadium application and so on?
Well, here what I show is just simple navigation sample, which has the localization. For example, the two digits, two numbers on top of the screen is the localization components, as well as I have the navigation path generated. As you can see, now there's no floor plan.
We don't see your phone at the moment, if that's what you're trying to show.
Yep.
There we go.
See, now we don't have the floor plan displayed. This is how it's supposed to be.
Yeah, that looks fantastic. So how about tutorials and training materials? Do you all have that available? I know this will act as a great resource because this has been really informational on how to build these applications. But do you have any training material or tutorials out there for folks who want to learn how to build these?
Yeah, we have this for example, for this kind of sample project, we have documents telling you how to build this sample project step by step, and which is For example, if you go to Immersal's website, this is the official tutorial document. If you scroll down, go into Immersal SDK, sample scenes, for example. This multi-map sample, for example, is this multi-map sample is the easiest sample, which is the best one you get started. And the navigation sample is the one which I just showed. So if you read this document, it tells you step by step how to build everything from the scratch.
Awesome. Very cool. Yeah, and folks, we will be uploading this to YouTube on the AWS Howdy Partner YouTube page after. So no worries if you want to grab some of these URLs later and watch this again offline. That be uploaded to YouTube in about a week or less.
Yeah, that's pretty much I have today.
Yeah, that was a lot. I mean, at the beginning, we went rapid fire through all the different use cases, which was really, really good to see, you know, the different industries and use cases that you can use this kind of technology for. I think that was super informative. And yeah, that live demo really just showed us how easy it is to put some of these together. We did that all in about 30 or so minutes. So that was really interesting and informative to see all that.
Yep.
So yeah, Mal, thank you so much. Any closing comments before we wrap up here?
Yeah, not much. Just very glad to be here. And in case anyone have any other questions, please feel free to contact us. For example, you can post your question in our Slack, in our Discord channel. You can find our Discord channel over here. If you go to Immersal's developer portal, you can find the link of the Discord channel. And anyone you can post your question here. We can answer you there.
Awesome.
Yeah, thank you for hosting the call.
Awesome. Well, Mel, thanks so much for being on the show. It was really awesome to see Immersal live and you know, how to build an application, and like I mentioned before, all the different ways that you can use this kind of technology. So huge thank you. This is actually our last spatial computing episode of this year. There will be more episodes throughout the year, but this is our last spatial one. So tune in next year for some more spatial related episodes. But Mal, again, thank you so much for being on the show. That was really awesome. And to the audience, thank you so much for tuning in and sticking it through. Again, you'll be able to watch this again on YouTube. And yeah, tune in next time. We'll be here again next Wednesday, same time.
Thank you.
All right. Thanks, everyone.
Have a good one.
Bye.